mode.
Good evening, everybody, and welcome to another exciting AWS version of vBrownBag. This evening, we are excited to have back Mr. Tim Carr, who just passed his SysOps certified associate certification. So, congratulations, Mr. Carr. You are perfectly positioned to talk about it this evening.
Well, thank you very much.
So, a couple of housekeeping notes. Both Tom and I are hosting this evening. Tom Green's on as co-host. Welcome, Tom. Hey. And please get in on the conversation. As always, you can follow us at vBrownBag. If you Twitter hashtag vBrownBag, we'll see the question live. Or if you're in the audience, obviously give us a shout through the live forum. Once again, our guest is Tim Carr, and I am Chris Williams. Tom, would you like to introduce yourself?
Hi everybody, I'm Tom Green. I'm on Twitter at TBGREE00, and I look forward to speaking with you guys a lot in the future.
Can I tell you how many times I fat fingered that before I got it right? TBGREE00. That was it was tough for me.
Yeah, it's almost like a color, but not quite. So I can see where that could be a problem.
All right, Mr. Carr, make presenter. There you go, sir.
All right, and then I'm going to work on sharing. Let's see here. Let's do that one. And then we'll do that bad boy. And here's where I always wonder about things. Is everybody seeing my presenter mode, or are you seeing the good mode?
I am seeing nothing as of yet.
Okay. And how does that look?
Now I see it.
I love it. I love it. Okay. So, as we alluded to, and as we get going here, I'm Tim Carr. I'm a senior solutions architect with a head out of Chicago, and this is vBrownBag, part of the series where we're discussing the SysOps associate certification that they have. I've been asked to cover off Domain 3.0, which is a section that's entitled Analysis. So that's quite a quite a broad term. So I guess what we first need to do is get some silly housekeeping things out of the way here. So let's do that. First, the obligatory "Who's Yapping at You" slide. I'm Tim Carr. You can find me on Twitter at Timmy Carr. I do a little bit of blogging at timcarr.net, and you can catch me there. I have some VMware certifications. I've been working on my AWS certifications. I think, I love what vBrownBag does. So whatever I do, I try to stop, write some stuff down, and give back as soon as possible. And that's what this is really all about. So I also want to take a second to throw a plug out there for people who may be wanting to do this in the future. Please reach out to the vBrownBag crew. They're great. They'll help you learn how to present online, and they'll help you take the stage to do this exact same thing. And I think it's something that everybody can do. They're fantastic. So make sure that you try to do this, people, because it's great for your personal and professional development.
Full disclosure, we pay Tim to say that.
Absolutely. Thank you. My PayPal account just went clink, clink.
Ding, 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 ding.
Exactly.
Okay, wait, is that why I can't get paid this week?
No. I actually took your money, Tom. Sorry. You gotta pay the guy, right? That's so mean.
That's BS, man.
So let's talk about what we're going to cover, right? And if there's some auto advances on my slides, I'm sorry. I'm not a PowerPoint genius, so excuse the flipping back and forth if that happens regularly here. But I was asked to cover Domain 3.0 from the SysOps Administrator Exam Blueprint, and that's specifically focused on a few different areas, right? It's analysis, and when they talk about analysis in the blueprint, they're really talking about things that you can do to optimize your environment to ensure maximum performance, right? They're talking about identifying performance bottlenecks and potentially what you might do to implement remedies for those bottlenecks, and then identifying potential issues of given application deployments. And man, just like every AWS blueprint, it's really broad. It's hard to understand what goes into all these buckets. And I got to tell you, I think I finally started to understand how they classify things after finishing like now my third associate exam. It's just so broad and it's hard to figure things out. I will pause there and say I think it's really valid to kind of group this analysis section in with the monitoring stuff that Byron Schaller did in week 1. So make sure that you go back and have a look at these other videos that are available. And I think those are on the site. Am I correct there, boys? Those are already on the site, and they're also on YouTube, correct?
Yep, that is correct.
Okay, so make sure you have a look at those. I'm probably going to cover a couple things that we've already talked about, only because I feel like they're important, and probably going to cover off on some things that you might have already heard about as part of other exams, but they are definitely pertinent to this exam as well. So, you know, this can stand on its own, but I recommend looking at everything as a whole thing as you work towards your cert. Okay. So we've covered what we're going to cover, but first we have to insert a small warning, right? And I decided to think about this because I understand that, you know, while we do have a good group of people here to look at this today, we really need to take a second to understand that AWS is a constantly changing ecosystem. So number one, read the AWS documentation with what's related to the exam. That's important, right? So even what I've talked about here may not be the way that it actually is by the time you see this video. So please don't take this as the written truth. I would say play with all of the services. And then finally, dominate the exam after you've played with all the services and read all the AWS documentation. And to do that, I'm going to work on helping you with some strategies that I had because, frankly, I'm a terrible test taker. So I'd like to, before we even get started there, talk through some basic exam tips that I have for you. And excuse me while I get my cat off of the computer. I apologize. He loves to be a part of the vBrownBag podcast as well.
I just did the same thing.
Right? I mean, the second you start talking, the cat jumps up and he does not like to be taken off the desk afterwards. Yep. So anyways, basic exam tips, right? Make sure that you read every question slowly. And you know what? I even do it in my, I will read it and, you know, I'll move my lips a little and like whisper the dang question to myself really quietly because I find that helps me internalize the question. I'm the type of person that has to have some sort of like kinesthetic link to the question. So that might help you. And make sure you ask yourself what the question ask is, because we all know that ask is now a noun in today's world, right? So after you figure out what the question's asking, you need to break that down into a couple things. Like when you're asking yourself what the ask is, you need to know if the administrator is performing an action. If so, what's the exact action? Are you identifying something like a problem in your environment? Do you have to configure something? Or is the administrator simply attempting, and I've seen this one, this is kind of a confusing way to think about things, but attempting to gain a better understanding of a service or maybe a part of a service. And so a question might be geared towards asking you or saying something along the lines of, you know, tell me a little bit about what an administrator might expect for this part of a service. Tell me what better describes this part of the service. I see questions like that on exams, and I think that they're kind of a tricky way of questioning, right? In general, things are pretty straightforward. The other type of question that can kind of be tricky is a question that kind of gets into design of a service, and that can even go beyond what the AWS platform is, right? So maybe you're talking about a scenario where you're talking about an end user's web application that they're going to platform on AWS. Understanding that platform requires some knowledge outside of the AWS platform, some basic knowledge about how applications are built. So trying to understand application like taxonomy is really helpful as well from an overall thing. So I would, as you're doing this, make sure you're going through and taking all of those prep questions that they have on the website. Make sure you go through those and try to identify how Amazon is asking each of the questions that they're asking. What the ask of the question actually is. I think that's probably the most important thing that I can encourage you to look for. So use all of that data that you've gathered and then identify and rule out the answers that just don't make sense, right? That's rule number one. So typically you can take an answer and eliminate one, right? The next thing that you can do is you can see that there's two or three answers that could be plausible. And in general, you want to pick the question that is the most accurate. But I always tell myself, go back to what the ask is. After I've identified that last thing, go back to the ask and say, okay, are we trying to better understand the service? Are we trying to design something? Or are we trying to configure something? Because I can get tripped up personally without really having a good idea of what that looks like. Okay. So let's just do an example of this, right? And I think that, you know, this can kind of be helpful. Like I put one together that can kind of be tricky, just a little bit. It's not really designed to be tricky, but I think the answer ultimately might be. So let's imagine that we have some file objects that are currently platformed on-prem in 2 different facilities for data protection purposes, right? What solution may be suitable for replatforming this data in the cloud? EBS, S3 storage with replication between regions, S3 storage with archival to Glacier, or just S3 storage? And it's a really interesting question and a really interesting group of answers, right? What the question kind of infers is data protection. Well, maybe that's Glacier in this scenario. Or really, is it about data durability? Because if it's about data durability, S3 solves that problem. So in my mind, I've eliminated EBS already, right? So just get rid of that. And then finally, get rid of EBS. It might be Glacier, right? That could happen. S3 storage with replication between regions. Okay, that's kind of complicated. Well, what's the ask? Okay, currently they have these file objects that are platformed in 2 different facilities. Okay. So let's take that to an AWS construct. What are 2 different facilities? I would say those would be availability zones in a region. And I think that kind of leads me to answer this question kind of like maybe it's S3 storage in general, right? And that's kind of my methodology that I have in my head when I walk through how to eliminate answers, walk through how to eliminate different scenarios, so on and so forth. I think that the thing that muddies the water on this question is data protection purposes, and I would consider that question. So purposely worded this question so that it was a little bit confusing as to what we were looking for, but I think if I were to get this one on the test, I'd probably answer just native S3 storage. And it's important to kind of walk yourself through that methodology. Okay, so let's jump into some basic, sorry for flipping back and forth there. Let's jump into some basic things that I see when I'm thinking about analysis. You know, when we talk about looking through our environments, if there's a problem and we're analyzing a problem to try to resolve that problem, and then we think about that problem as a whole, and how to fix it, right? There's some basic things we need to do when we're in firefighting mode, right? And I think this one's been covered previously, but I think EC2 status checks are really important and are something that you may or may not see on the exam. But I think what you need to know about EC2 status checks is that they happen every minute, right? And they augment the information provided by the EC2 intended system state, meaning that like if the system is either in the pending state, the running state, or the stopped state, right? Status checks kind of equal, is this thing healthy at the end of the day? And it really equals a sum of system status checks and instance status checks, which are, if you log into that AWS console and you fire something up, you see the little 2 out of 2 with the checkbox. That means that both your system status checks and your instance status checks are good to go. Let's dive into those really quickly. And I'm sorry for the person whose Echo Dot thinks that I'm Alexa, so sorry for everybody there. So from an EC2 system status check perspective, I think the thing that you need to know about EC2 system status checks are that these are the types of checks that are going to monitor the AWS infrastructure itself. And these are things that are going to require AWS intervention to solve. So this is loss of network connectivity, this is loss of power, physical host software issues, the physical host being like hypervisor, physical host hardware issues, that being the hypervisor as well. So there's two options to correct this when you see that problem. You can either wait for Amazon to fix the issue, and that may or may not happen, or you can start and stop your instance. So what's happening when you actually or stop and start your instance on the background is, you're unscheduling your instance on the AWS infrastructure, and then in powering it back on, you're actually rescheduling it, and you're likely just getting a new host in the background. We'll talk a little bit more about what AWS is doing in the background for placement. Basically, their placement algorithm under the covers determines whether or not a host is healthy and can take new workload, and if so, it will place a new object there. So a simple stop and then start of your instance, while it will cost you that extra hour, right, and that's important to know, will help resolve that issue from a system status check perspective if it's something that's related just to that host. All right, let's talk about instance status checks. So instance status checks are the type of thing that are going to relate to parts of your actual infrastructure that you control, and these are really things that are happening inside of your instance OS, right? So maybe you've got like like an incompatible kernel, maybe you've got a corrupted file system, maybe you have an incorrect startup configuration for your two things. And what's wrong here, what I actually have wrong here on this slide, and I'll fix it in post, is that the option to correct this issue is not wait for AWS, because they're not going to help you here. This is your problem. You've got to get out there and fix it, unfortunately. So while waiting for Amazon to fix this issue might help for a system status check, it's not going to help for an instance status check error. So the big thing to understand here is that if you come across a problem where you got a system error and one of your two is red and it happens to be system, you're going to stop and you're going to restart your instance if possible. I say that with some caution because what you need to do when you do that is you need to understand that the architecture that you're working with, meaning that you might not want to do that if for example, you're going to lose data on a host that's not recoverable for some reason. So you need to understand how you've configured your architecture under the covers. Okay, EC2 Auto Scaling and Scheduling. There's a lot of things here, and realistically, a lot of this is just taken directly from the AWS documentation, but I wanted to cover off on a few of these, and it's kind of an eye chart. I'll keep it up there for you. Let's get one of the easy ones. You can create a maximum of 125 scheduled actions per auto scaling group. Know your maximums. Maximums are the type of thing, and I found this for the AWS certification exams. You usually get a couple questions about maximums. They're not all over the place like they have been in traditional IT exams, though. So knowing them is good. I would stick to the basics in knowing your maximums. This one I'm just calling out here because it happened to be as part of the scaling scheduling considerations. So auto scaling guarantees the order of execution for scheduled actions within the same group, but not for scheduled actions across groups, right? Meaning that one auto scaling group is going to do its own thing as far as execution goes for your scheduled actions. Scheduled actions generally execute within seconds, but they may be delayed for up to X number of minutes, right? It says 2 here, but really X number. It's going to happen as quickly as it possibly can. The most important thing to note here is that whatever action that auto scaling is going to execute, it's going to be executed within the order that it's specified. With one very glaring caveat that I really want you to be aware of, and that's scheduling conflicts. So a scheduling action's got to have a unique time value right? And if you attempt to schedule an activity at a time when another scaling activity is already scheduled, the call is going to be rejected with an error, meaning that if I have a scale up and a scale down at the exact same time, scheduled for the exact same time, you're going to have an error that hits your inbox there. It's not going to work. So note that as far as EC2 auto scaling goes. You know, those are the big ones that I wanted to hit right there. I think you know, we've covered a bit so far. I just want to make sure that we're doing okay as far as questions go and so on and so forth. Are we good so far?
Oh yeah, no, we're definitely good.
Yeah, I don't see anything out on Twitter myself other than some typical rabble rousing, and I'll call that out as I see it.
There are shenanigans happening.
I saw the shenanigans on Twitter. I appreciate it. Trust me, everybody. It's part of it, part of the gig, and you know, it's fun. It's what makes doing this fun.
Throwing virtual tomatoes.
Yes. Boo, Tim, you suck. Let's talk about placement groups.
I think you did cause somebody's echo to go off and maybe have bought a dollhouse.
I did hear the beep.
Okay, let's talk a little bit about placement groups, because placement groups can affect performance, right? And my section here for this analysis is really all about, you know, how can you architect something to be as highly performant as possible, right? So placement groups, right? They cannot span multiple AZs, right? And that's important, but you get a whole bunch with a placement group, right? A placement group is all related to network connectivity. So what you're dealing with a placement group is one availability zone. So if the availability zone goes bye-bye, okay, well, bye-bye to everything in that placement group. That's important to understand, right? So there's that consideration when using a placement group. But that said, you can architect everything within a placement group to be to have incredibly high throughput and incredibly low latency from a networking perspective. And so this is really good for, you know, like Cassandra databases. This is really good for perhaps EMR workloads. Really good for anything that's very latency sensitive, because what you're going to be running across is this 10 gig networking backbone within one AZ of Amazon's data centers. So really, really high performance, right? There's a couple of considerations that you need to take into account when you're leveraging a placement group. One is that, you know, in general, it's a best practice, and man, I hate that phrase, because a best practice is really your practice that you've defined as an architect. But a best practice in this scenario is truly to leverage the same family or size, same family and size of instances, and that's due to reservations, and that's also due to the capabilities of each of those instances, to the way that they're architected. So be aware of that. If you're going to use a placement group, try to use the same size and family of instances. One other thing to consider is that, you know, just like, and this is like a core Amazon tenet, just like anything, you can't take something that's not in something and place it in something, and from an EC2 perspective. So you can't take an existing instance and put it into a placement group. You know, what you would need to do is you would need to do the whole create an AMI from your existing instance, and then launch that in the placement group. If you just think about it, it's like kind of in the back end, if you're relating it to like VMware terms, it's like there's no vMotion and so on and so forth that they give you the capability to do. So once again, you're kind of lifting and shifting to get it into placement group. All right. Let's move on to initial EC2 placement. And I call this out as just make this a design decision, okay? Okay, folks, like this is serious. If you're going to deploy your first instance of any application, right? Don't pick an AZ within a region. Let AWS do it, and that goes back to understanding. AWS has a broad understanding of the reservations in their environment. their system status and the performance of each of these availability zones at a time. And so by just letting AWS do the selection, you're going to get the best possible performance for your initial EC2 placement. Clearly, this goes out the window after you start designing for like high availability within different availability zones. Clearly, if you're going to pick one AZ, you're going to have a different AZ for your second web server, right? So just one thing to consider. But as far as initial placement goes, just have it in your mind that if you're going to just deploy one thing, let Amazon pick, because their scheduling algorithm is smarter than you are. That's why they're Amazon. I'm sorry, it's true. They're way smarter than all of us. Okay, so let's talk a little bit about EBS performance. So in terms of EBS performance, once upon a time, there used to be this concept of pre-warming blocks of EBS storage, and that was essentially to get locality of the bits to your area of the data center within AWS. That's not happening anymore unless, and this is actually quite a big caveat to have in the back of your mind, unless you're actually attaching and running a snapshot, an EBS snapshot. That EBS snapshot is stored in S3, right? And ultimately, when you attach that volume, what you're doing is every time you read a block, you're reading from S3, and it's being written to your volume that you're going to be in the future reading and writing to. So it's important to kind of understand that design consideration. For example, if you were to attach a snapshot to an instance that was running, I think that if you were to attach a snapshot in like a different, let's say AZ or something like that, and you fire that thing up, you're going to get really poor performance until all of those blocks are actually read. Or I shouldn't say poor performance, that's not accurate. Inconsistent performance is perhaps the better way. I think what you really want to do, and what people will argue that you do, is that you actually read all of the files that are available, and what that will actually have the purpose of doing is writing those down to disk. And I was doing a little bit of research on this pre-warming thing beforehand, and this is why I wrote that slide in the beginning that things change in AWS. This didn't work like this until recently, apparently. So I learned something. Is that the way that everybody else is hearing about it working today? I mean, is anyone heard anything different?
I have not heard of pre-warming recently. I mean, like you said, it used to be a thing, but not. I don't know when it went away, but people stopped talking about it. I want to say about 4 or 5 months ago.
Yes. I think the same thing. So remember, pre-warming, not a big deal unless you're using a snapshot, right? And that makes sense because of the way the snapshots work. I'm sure Amazon will continue making improvements and continue to be even more amazing in the future. So this slide's probably, doomed for the dustbin within 6 months. So, all right. So we're going to talk just a little bit about databases, and just doing a quick time check here. I may have to speed up. I think we got to make it through about 20 slides all of it. So, databases. So RDS has a ton of feature and functionality, right, that makes it compelling. And it's important to know that RDS is a traditional relational database. In all flavors today, they're relational databases. And relational databases are typically limited by storage and memory performance. You could argue that there's CPU limitations for some relational databases today, but in general, those are nowhere near the level that memory and storage have classically been for those platforms. So as such, they're mainly scale-up type problems to deal with in the relational database platform. So I say this to kind of push you towards, if there's a performance issue that you're seeing in your perhaps RDS for some reason, and you're wondering what they are. I think performance-wise, the first things that I would look for, right, I would look to understand what my disk stuff looks like, and I would look to understand what my memory stuff looks like within the instance, right? And that's write latency from a storage perspective, and number of IOs might just get hammered. And then if you're running multiple availability zone RDS, a good thing to understand would be, how far behind is the read replica from the master, because that could signify some challenges with that host as well, or with that setup as well. And if that's the case, maybe you need to scale up. And when I say scale up, I'm talking about a bigger instance size, and I'm talking about maybe storage that has more I/O capability, right? So those are things that you can do in that scenario. So just know that RDS typically scale up in your environment, and the things you want to monitor are generally memory related. Of course, you're going to look at CPU and be able to see that. But then also disk, and those are the key factors that you want to be watching on those instances. Okay, so I would say watch for use case questions here. We already talked about understanding, application-centric focus. RDS is a good choice for, your typical applications, but maybe you have an application that's NoSQL. Understanding the difference fundamentally under the covers between, and not even really understanding the true difference between the two, but really understanding that RDS is a relational model and NoSQL is typically scaled out amongst many nodes is helpful, because what you can get out of that are different design choices, right? So in a NoSQL model, for example, you might have many nodes that are scaled out to make one big aggregate of both throughput and capacity for your data structures. So in that case, when you're thinking about NoSQL, understand that they're usually designed to be fault tolerant by kind of node that's included in the environment. So a NoSQL design scenario or NoSQL use case might be best served by something that's not taking advantage of disk that has to be resilient through things. So maybe you're looking at using like instance-based storage or SSD-based storage in a scenario like this. Whereas RDS, you definitely want to make sure, well, not RDS, but in a relational model, even if you were to install, say, SQL Server on an instance, you would want to make sure that you were protecting the volumes by using EBS that your database is running on. So just have in the back of your mind the difference between what a relational database looks like and what like a NoSQL database looks like. All right, multi-availability zone versus read replicas. This is a common kind of misconception. I want to make sure that it's cleared up really quick. A multi-availability zone instance within RDS essentially uses one instance at a time. Okay, it's important to understand that by leveraging one instance, what you're doing is when you do a write to that instance, that write is being committed across to your other database instance, which you don't have access to. As a matter of fact, Amazon is monitoring for the availability of that instance. And what you're actually able to get out of that is if there's a problem, Amazon's going to do a DNS switch, a DNS update to make that other host the host that you're actually talking to. Now that isn't going to be seamless to your end users, something to know, but the service is restored relatively quickly. So the DNS record is going to be updated, and you're to the other host on the other side, and you're going to get a disconnect, but you will have service with all of the transactions that existed prior to the failure because of the replication between the two. So what would we use the multi-availability zone for? Ensuring that we have availability as best as we can, and then we have all of the transactions at that point in time that they existed when they were committed to the host before the failure. So it's for your applications that must have consistency between the two. There's other models, right? And I want to before I get to the other model, I want to make sure that we understand the things that might actually cause that failover, right? And I've listed them here. You know, I think the one thing that I would call out is go to your documentation and understand, if you're leveraging Mutli-AZ RDS, exactly what the process looks like for Amazon doing their system maintenance of the RDS platform. They're very specific in terms of what gets patched and how the failover occurs, and in exactly what order that happens. It would be good to understand that as a whole, and I would definitely get that from the documentation. And let's see here. Yeah, automatic failovers triggered by any of these listed things that would happen here. Let's talk about read replicas really quick. So when we talk about read replicas as an architecture choice within your environment, the thing to understand is that a read replica is not necessarily getting real time what exactly note for note what was written to the master. The master is shipping data as fast as it possibly can to the read replica, and the read replica is pretty close. That's the best way to describe it. So if you have an application, from the application perspective, and you know, maybe that's one way to look at it. If you have an application that requires a user to, you know, make a transaction or something like that on the master database, and you need to know exactly what the master database looks like, your application is going to have to be set up to query that master database and not the read replica. If your application can take a little fluff and doesn't have to have all of the capabilities immediately available to it, it can definitely query the read replica of the environment. So the reason why I say this is because there's potentially a model here where you could leverage a read replica when you really don't care about the consistency all that much in this scenario. And I would say the one other thing that I would note about that is perhaps you have a scenario where you're doing a transaction on the master side, but then you have like a business process that needs to run and do some querying. That business process could potentially just query the read replica. You should be noted that the read replica is exactly that. It's just for reads, right? So I like to call this out for the business logic use case on the other side.
And to clarify, what one person just asked, when you say a little bit of fluff, what are you talking? You know, multi-second, sub-second?
I think that's a great question because it goes back to something that I said just a little bit earlier. Depending on your application's performance characteristics, and depending on how you've configured your master and your read replica within RDS. So let's say you have it on some slower disk or something like that, or you have an instance that's undersized. Your lag time between the data on the master side and then in the read replica could be quite large. And that's actually something that you would want to monitor. You know, that's something that maybe your business wants to know about, and so that's something that you might want to look into looking at with CloudWatch, making sure that you stay under, you know, X amount of threshold for the synchronization between the two. But the little bit of fluff means that the read replica does not necessarily always represent the truth of what's in the master. So use it for applications that require, I guess you could say, eventual consistency on the reads.
Cool.
And from a troubleshooting perspective, you know, have that in the back of your mind. Read replica, not necessarily 100% there, but might not be. But if the delta between the two is really big, maybe you need to upsize your instances. All right, let's talk through Route 53 really quick. The reason why I want to talk through Route 53 is because the things that we care about, well, the things that I care about from an analysis perspective and solutioning for Route 53 are all really related to the routing policies. I would say that, you know, simple, we know how that goes. That's machine gun. It's just like that one, that one, that one, that one, that one. It just cycles through the available endpoints. The weighted routing option specifies only X portion of your traffic should go to one endpoint. So and I think that this is important. I could see a use case here, for example, if you were, an e-commerce company and you had a new test that you wanted to roll out, you could use a weighted routing policy to say, oh, X percent of the requests should go to my new looking application. And you can use that for user testing and so on and so forth. So know that weighted routing allows you to specify, hey, we're going to throw this amount of the request over that way. Failover routing, I look at this as almost like HA, right? And as a matter of fact, it's not a bad way to look at it. You could use failover routing to give you access to services that were set up in two different availability zones. Like, let's say you had like a jump host that you needed to get to, and that was running in a public subnet or something like that. I would leverage failover routing to ensure that you have the capability to access at least one of the jump hosts at a time if you needed to get into your environment. Not a bad use case for that. Latency-based, fastest DNS response time wins. This isn't bad if you're trying to serve up your website really fast. Latency-based capabilities allow you to, regardless of where you're at, get to a certain site. I would say with latency and geolocation, be very careful in compliance scenarios based on compliance rules and so on and so forth. These do not account for borders. Right? This is functionality of certain sites. Geolocation could potentially, but and latency-based will not. But be careful with both of these in compliance scenarios. It's very likely that your application, if you require compliance to keep data and or user access within certain borders, it's very likely that you're going to have to write some other functionality into your application itself.
I know exactly which question you're talking about because I got the same one.
Oh, really?
Yeah,
awesome.
I did.
Awesome. Well, I mean, it's like I would say be very careful in compliance scenarios here, right?
Yep,
that's
exactly.
The one thing that's the one thing to note. And I would say that all of these could be questions, right? You need to know all of these, absolutely all of these. But this gets back to the what's the ask, right? And do these really meet the ask, right? So I think there's a lot of thinking that has to go into how you look at those questions. Pre-warming of the ELB. Okay, this is something that's not super commonplace, but in Flash traffic testing scenarios, you might need to raise a ticket with Amazon Web Services to support to have them adjust your load balancer. So this is, let's say you're running, 1-800-Flowers and it's, October before Valentine's Day and you're testing your app. Well, if you're the admin there, you're probably going to call Amazon and say, okay, I want to test my app that we're going to run this Valentine's Day. I know that I'm going to get X amount of load. Amazon can go in, click the buttons and say, hey, you're adjusted. Go ahead and run your load tests. While ELB will scale, it will not scale at the rapid pace that you really need it to do like a performance load test. So understand what pre-warming is, and understand how it's not related to essentially the normal, I guess you could say, operation of ELB in the Amazon environment. It's kind of an edge case. All right, instance networking bottlenecks. This is something that is, I would honestly say something that is less of the issue in AWS than it once was. Just understand two things. Your NIC in your EBS in your AWS instance is responsible for a couple things. It's responsible for the network traffic, and your NIC can also be responsible for your storage traffic. And so depending on how things are configured. So you've got two sorts of options here. EBS optimized would allow you to have awesome storage performance in your environment, and that's one sort of way to alleviate a storage-based networking bottleneck. The other thing to consider is that, if you're running a T2 micro, you could have performance issues. Scale that bad boy up. Get a larger instance with better networking performance. That's the one thing that I'll say about networking bottlenecks. In general. From an instance perspective, it's not an issue, but if you do run into those problems, these are a couple ways that you can help alleviate those. Okay, let's see. How are we doing on time? Not bad. I have a few more, and then we're almost out of here. So from a networking security group and NACL perspective, right? This goes back to try to figure out what questions being asked, right? In general, I would say leverage a network ACL to deny access and security groups to allow access, if that makes sense. So for example, if you want to block a bunch of access for a known set of malicious like IPs that are hitting your environment, that's probably a NACL that's going to happen. But remember, and I want to make sure that's not on a, well, it may be, but remember that NACLs kind of map, NACLs map to your subnets in your environment. So you need to make sure that you have one NACL to one subnet, from what I understand. So NACLs are also stateless. So any rule that you create with a NACL, you need to make sure that you have an inbound and an outbound rule to make sure if you want to let traffic flow appropriately, that it can happen. So whereas a security group is stateful, like if you open up an HTTP request and make a request from an instance to the internet, your security group is actually stateful. It understands that request is happening and it allows that the request to happen. If you were wanting to do that on a NACL side and you only did half of it, you wouldn't get a response. Unfortunately, you have to have an inbound rule and an outbound rule as it relates to NACLs. By default, NACLs in your environment are set up to allow. You can use but you can use NACLs to both allow and deny. So you have a NACL associated with your environment. When you're setting that up, it is set to allow so that you can come in and start blocking people. Security groups are by default deny all, and you specify what you want to allow. So just a couple of things that you need to understand there.
We actually have a question that came in.
Yeah.
Storage over network on the AMI VNIC, huh?
I think it's a question about EBS versus ephemeral.
Yeah, that's a question about EBS versus ephemeral. So in general, they're using a networking-based protocol to get storage traffic to their boxes in AWS. So if you're attaching to a volume, you're going to be leveraging that NIC to do it. I'm unsure as to whether it is that single NIC or a separate NIC. I don't know that much, so I'd have to study and let you know about that. But that said, what you would, in the event that you're having storage-based networking performance, meaning that you can't get the bandwidth that you're being allotted, you may need to specify that you need an EBS optimized instance. In the event that you can't get the networking bandwidth that you need from a physical networking capability, you may need to specify that you need in a instance that, yeah, enhanced networking. Yeah.
That makes me think that it's two separate things, because EBS, you can have an EBS optimized but not enhanced network, and an enhanced network but not be EBS optimized. So I think.
Yeah, I think you're right.
I think it's coming out two different paths, but I'm also not sure.
Yeah, I'm not 100% sure about that. I think the thing that I really want you to take away is that that you need to select the optimized version in the event that you're having some performance scenarios, performance problems related to that. You know, just some basic things that you can do to immediately alleviate a scenario like that. Okay, VPC configuration scenarios. If you're going to connect to VPC, you either need an internet gateway or a virtual private gateway. And by the way, from an internet gateway perspective, you only get one per VPC. Just know that. Just know those, right? Remember also, and I know that this is kind of silly, but you know, at the associate level, I think it's really important to just keep reminding yourself this, because for me, the questions get really long and they get really convoluted and tricky, and I've never done well on tests like this. Remember that a subnet, no matter what, equals an availability zone, right? Also, remember that you just can't go resizing a VPC. When you specify the CIDR for a VPC and the network that's going to exist in the VPC, you can't go resizing that. The only way to change that is to destroy the VPC, is to migrate and then destroy the VPC. I mean, there's not an option. So make sure that you're aware of that. You know, I'll see scenarios where it seems like you may be able to change something, but realistically, in general, you can't, and you have to get rid of it and build a new one. All right, I think for me, that's all I have. I think we're kind of running. We're not running bad, right?
No, we're doing good. We've got 9 minutes left.
Nice. Nice. Well, I think those are the slides that I had, and that's covering pretty much configurations. You know, anything else that we might want to talk about that you guys are thinking about when it comes to analysis? I was kicking my head about services and things we'd want to talk about, but I think I kind of hit those with Byron's monitoring stuff.
Yeah, one question that popped up was what were the study materials that you used? I mean, other than the white papers and
yeah.
the regular stuff.
Yeah, I use the white papers like crazy. I'm really lucky to work at AHEAD. I use
yeah.
I use our I think we have 6 Sol 5 certed guys, and they are just really smart. Like, I'm not even close. And I use AHEAD Slack, number 1. I would also say that I definitely read the documentation because I think the documentation is really good. I gotta shout out, I gotta give a cloud guru a hand as well. Ryan Kronenberg stuff's really good. I think that's a pretty good way to go about it. But that said, I don't think you can really use any of the online stuff and expect 100% to pass. I think it's a combination of I did maybe some online training, I've read the docs, I knocked out those practice exams. I think you have to do all of those to be successful because in the end it's really a lot to internalize. And then more importantly, sign up for an account and go do, like, you know, go build a VPC from scratch. Don't use the wizard, right? Go do that and understand everything that takes to go in there. Go set up all of these services. Go tear them down. And I would like to emphasize the second part because I 100% know that there are questions that relate to can you destroy something, you know, out there that you need to understand as well. So make sure that you understand both how you create something within AWS, but then also what it takes to actually delete it.
Exactly. And the last one that we had, Byron actually had a really good recommendation for that, was to, if you have your own blog or if you have a website, cut over to Amazon. You know, rip it out of wherever you have it today, and you know, set up like, you know, a 2-instance auto scale group. Set up an ELB. You know, turn your domain over to Route 53. Learn it from the perspective of that's what's keeping your website up, and that's a really good way to get into the nitty-gritty of it.
Yeah, that's actually not a bad way to look at it. So I'm not hosting my DNS there, so shame on Tim. But I am hosting my my blog there. So I did follow those recommendations, and I couldn't agree more. That's the best way to learn by doing.
Cool. Let's see what we got here. Tom is doing his Twitter thing. Job well done.
And we've got somebody who requested you to move mistwire.com to AWS.
So full disclosure, that is Matt Braga. He actually contributes to Mistwire. So all of the NSX articles on Mistwire are written by him. So he's got a vested interest in that. He's learning about it as quickly and as furiously as I am. So Matt, we'll cut it over. Cool. All right. Well, I think that'll do us for the evening, Mr. Carr. Once again, it's always a pleasure having you on to present. Tim and I did the essay presentations back when vBrownBag did the AWS Solutions Architect Associate series. He and I both presented for that. So Tim and I go way back.
Way back.
Oh, years.
The best of friends.
Oh, we're besties. Cool.
All right. Well, thank you very much.
All right, Tim. Have a wonderful night, man, and give Mr. Krausen a slap in the head for me when you see him in the morning.
I sure will.
He's listening right now, so it's cool.
Alexa, order my kid a house. All right. Have a great one, everyone.
All right. Good night, Tim. Thanks.
Good night.